Hello and welcome to this edition of my IBM Rhapsody video series. My name is Frank, I'm a passionate Rhapsody user, trainer and consultant for over 20 years and love to share knowledge to help you to become more effective. In this short video I share with you my thoughts on what it takes to establish model-based system engineering in your organization, and where and how Rhapsody is used in this context, especially when it comes to the use of industry standards. A couple of years ago, in the early days of SysML and model-based system engineering, I received the following call from a prospect. Hello Mr. Brown, could you come to us for 2 or 3 days to teach my team in Rhapsody SysML so that we can do this model-based system engineering thing? I was so surprised by this question and its underlying expectation that I spontaneously replied, that's not possible. And the other side answered, oh, too bad. Looks I have to find someone else. That was not my intention. So I thought about a better way of saying what I meant, and this became the inspiration for the following slide. So let's take a closer look to his phrase and what it really contains. First take Rhapsody SysML. In fact, these are really two different things, Rhapsody and SysML. So let's separate them and then let's first take SysML. SysML is a graphical notation, an interdisciplinary language that allows us to describe and specify a system. It consists of 9 diagrams with a defined semantic. So here, in this video, the language is English. My English is not perfect, I don't have to be an expert in linguistics, but I have to know a basic vocabulary and follow some rules to share my ideas with you. Same with SysML. SysML is by far not so complex as English, but you have to consider some time to learn the basics. Then we have Rhapsody. Rhapsody is a tool. And a tool is an instrument to achieve a certain work. To create this video, I also use a tool to record and cut the video. And it took me some time to understand and learn how to use it. And I'm sure you have made the same experience using other tools. And with Rhapsody, we have a modeling tool with a rich set of features to do the work to perform all kinds of modeling tasks based or conform to the SysML and UML notation. So with this notation, we can build in Rhapsody, for example, a structural and behavioral model of our system. And we can test and simulate the intended system behavior. And in case of software system, Rhapsody can also generate embedded real-time code and many other things. All this needs time to be considered and learned. Now we come to the interesting part, this MBSE or model-based system engineering thing. And here I have to go a little further for the explanation. In fact, here we also have two things, system engineering and model-based. First take system engineering. System engineering is a discipline, an engineering discipline, with a long-lasting history and collected experience and best practices how to come from user needs to a real system that satisfies the needs. All these engineering tasks are defined in a system engineering process which defines what to do, the primary activities that must be performed to implement systems engineering. And there is a long list of different system engineering processes that are proposed by different international organizations. Very common to all system engineering processes is to decompose the system from requirements to functions to subsystem definition on one side, and then to integrate, test and validate it on the other side. In general, these processes can be or are mapped to lifecycle model. So here I take the V model as one popular example. Now let's take model-based. In former days, system engineering tasks were mainly performed by using documents and tools like Word, Excel, Visio, PowerPoint. All this information was in many ways disconnected. Engineering teams, disciplines were working in silos. The basic idea of model-based system engineering is to perform the task around a centralized model that binds everything together. Often you will hear the expression like single source of truth. So what we are talking about when we say model-based system engineering is in reality a paradigm shift from classic, disrupted, document-based engineering to a collaborative, model-based, interdisciplinary engineering. And to make a long story short, the important enabler in the context of model-based system engineering that brings all this together is called a method, which is a guidance that describes how to perform these engineering tasks with a graphical notation like SysML in a tool like Rhapsody. To summarize, the key enabler for model-based system engineering is built-up understanding and know-how in all these three things together: methods, tools, and notation, which can't be really established in 2 or 3 days. To sum up, I would like to show you where and how Rhapsody is applied in the overall systems development by keeping the V-model. Rhapsody is based on or supports industry standards, graphical notations like SysML, UML for software-intensive systems, and the UDP, the UML testing profile, a defined semantic for model-based testing. Rhapsody also supports other standards such as the Standardized Software Architecture for Automotive Electronic Control Units, AUTOSAR. So in general, we might start our model-based system engineering activities with requirements on the top left side of the V-model. Probably do some functional or architectural analysis and design. All this by using the interdisciplinary SysML notation and an appropriate engineering method. Later on we can hand over to software, and we can continue our software process with UML or AUTOSAR to create a structural and behavioral software architecture, and to generate code for embedded targets, or to import and export AUTOSAR XML files. On the right hand side, when we talk about integration, we can test and integrate the things from the left side, starting with unit test, component and system test, verification and validation. Here the UML testing profile UDP and the Rhapsody add-on Rhapsody Test Conductor comes into the game. All these things you will perform in Rhapsody in a single repository. Ideally, you make the right and left hand side activities in parallel. With the document-based approach, these were very disconnected. With model-based system engineering, you have the vision of making these connected, and run models and test them early on, and iterate the tests as you go down the left-hand side of the V-model. A major milestone of the model-based system engineering approach with industry standards like UML, SysML and UDP is that we say goodbye to ad hoc graphical representation, disrupted documents. A standardized language is a glue to bring all engineering disciplines onto the same page. To establish model-based system engineering, it requires 3 things: notation, tool and a method. A good guidance, the method, is without doubt the most important part of all this. I didn't dig into this topic today, but there are a couple of methods available. Driven by tool vendors, we have for example Hamony SE from IBM with Rhapsody, MagicGrid from Dassault Systems with Cameo. Also I would like to mention Arcadia, initially by Thales with Capella. The method is not based on SysML, but worthwhile to be mentioned. And there are also others like Software Platform Embedded Systems, SPACE, an initiative by the German Federal Ministry of Research, Functional Architecture for System Method, FAS, initiated by Lamm and Weilkiens, or the INCOSE Object-Oriented Systems Engineering Method, OOSEM. Which one you want to apply depends on your needs and context, but in general, it's a good idea to have someone who guides you here. I hope this information was helpful for you to gain more clarity in this point, and I'm sure I might also raise more questions. If you don't want to miss new videos, don't forget to subscribe today. If you want to receive our newsletter, go to evotion/newsletter. That's it. Hope to see you soon. Thank you and goodbye.